Hey everyone, welcome to how to convert an equation from polar to rectangular form. So we've already done from rectangular to polar, and now we're going vice versa. So let's look at a couple things we need to consider. Your goal is to go from an equation in terms of r and theta to an equation in terms of x and y. To do this, we're going to use one or more of the following equations. So the idea here is that we want to make sure that we pick an equation that we're going to know the rectangular form of. So let's look at some examples. I don't know if we'll do them all in this video, but we'll try. Okay, so to convert each polar equation into a rectangular equation, x and y. So let's look at the first one here, and we have the value r equals 5. So if we look at the equations that we have, we got to think to ourselves, well, which one should we use so that we'd actually maybe recognize the equation out of those four. So here they are. And so I could pick this one, then I would have 5 cosine theta equals x. I'm not really sure what that looks like. R, 5 sine theta equals y. And then we just have no value for r here. So it looks like if we pick the top one, okay, for r equals 5, we're going to look at r squared, okay, equals x squared plus y squared. Okay, so I'm going to go ahead and use that equation, and then I'm going to substitute in 5 for r, because that's what I know r to be. So I have 5 squared equals x squared plus y squared. Okay, so that's 25 equals x squared plus y squared, and I know that, okay, that's an equation of a circle whose center is at the origin, whose radius is 5. Okay, so now let's go ahead and look at part B. Okay, now part B says that we're going to look at theta being pi over 4. Now, the equation that I'm going to use in this case is going to be tangent. I'm going to use tangent of theta is equal to y over x. Okay, and now I know what theta is, so I'm going to say, well, tangent of theta, it's not theta anymore, I'm going to substitute pi over 4 equals y over x. Well, tangent of pi over 4, that's just equal to 1. So I can switch that and make that a 1. And then I have, that's going to equal y over x. So I can cross multiply and I get the equation y equals x. So the rectangular equation that represents theta equals pi over 4 is the line y equals x. And so let's move on to our third example. Our third example is r equals 3 cosecant of theta. So r equals 3 cosecant of theta. Okay, and just remember that cosecant theta is equal to 1 over sine of x. So let's go ahead and rewrite that, okay? So we're going to have r equals 3 over sine, and we'll say theta. That should be theta there. Keep that in terms, okay? So now I have this equation, and why don't I go ahead and cross multiply before I do anything? So then I'm going to have r sine of theta equals 3. Now remember that if we look back at the beginning, one of those equations we had is that x equals r sine, or r cosine of theta, and y equals r sine of theta, right? So this is the equation that we're going to use. So we're going to substitute for this y. Okay, so we're going to have y equals 3. So that's the line that represents r equals 3 cosecant theta. And now on to our last, but certainly not least, let's write r equals -6 cosine of theta in rectangular form. So this one's a little more challenging, and we save the best for last. So we're going to go ahead and just rewrite this. R equals -6 times the cosine of theta, and I'm going to go ahead and multiply each side by r. Okay? And now we're going to have r squared equals -6r cosine theta. Okay, and I want you to pay close attention to this because there's two things we know. We know that r squared equals x squared plus y squared from the beginning, and I also know that x equals r cosine of theta. So we're going to do a substitution here, and we're going to do a substitution here. Okay, so now we're going to have x squared plus y squared on the left, and that's going to equal -6, and we're going to change that with x. Okay, so now we have, it looks like a circle. Okay, but we have the 6x, but we're getting closer. So what we're going to do now is bring everything to one side. So we're going to have x squared plus y squared minus 6x equals 0. Okay, and now we're going to actually go ahead and complete the square. So we're going to have x squared, we'll just rewrite this, minus 6x plus y squared equals 0. I haven't completed the square yet, but now I will. I'll have x squared minus 6x. Well, you take half of 6, which is 3, square it, you're going to have 9 here. Okay, leave the y squared, and you're going to have that also equal to 9 because I added 9 to the left, I have to add 9 to the right. So that means now I'll have x plus 3 squared on the left plus y squared equals 9. Okay, so now that is my equation, okay, for part D. R equals -6 cosine of theta. It's just a circle with center at -3, 0 and a radius of 3. Okay, so that is how we convert from polar equation to rectangular form. 4 examples there. If you have any questions or comments, let me know. We'll see you next time.